Hi everyone. Then continuation of Unit 2. So now we are going to discuss about delta modulation. So this is another baseband transmission scheme. Okay. And so what is delta? Why we are going for delta modulation? Whereas in pulse code and digital pulse code modulation, whatever the bits we are encoding, we are transmitting all those bits together. So what will happen? So this will increase the bandwidth and signal rate. Okay, so to overcome this problem by delta modulation, here we have only a two level which is represented by one bit, either positive delta or negative delta. So that is one bit version of DPCM, digital pulse code modulation. Okay, and here we are using staircase approximation method for input baseband signals. So why we are going for delta modulation? In pulse code modulation, we are transmitting all those datas, whatever datas we are sampling and encoding, transmitting all those datas together, so that the signaling rate as well as bandwidth increases. To overcome that with only one bit and two levels by delta modulation. Okay, so that's what we are going for, delta modulation. How that is achieved? Okay, see the waveform diagram. So the signal is going up. That staircase is there, no? That staircase is on gradually it's increasing and decreasing, gradually increasing and decreasing. Whenever the staircase is going up, that represented by 1, and whenever it's going down, it's represented by 0. That is step size. We can say here as a step size. So it is going from 0 to 1, represented as plus delta, and going down, it's represented minus delta. So plus delta, so 1, minus delta 0. That is the simple logic. And so for this entire signal, so in under that graph, binary 1 bit sequence is there, no? First step is going down, so it's represented by 0, and second one is going up 1, third one, fourth one, fifth one, sixth, seventh one, and eighth it's getting down, so it's 0. So likewise this sequence will be there. We are going to instead of, whereas in DPC what we have did, we are making levels. Okay, with the help of, for single if I am taking a 3 bit, so each discrete time we are making as a 3 bit data, 3 bit say sample. Okay, whereas here we are making only one bit, 0 or 1. So that is the beauty of delta modulation. So what are the things I have explained you, that is presented in working principle. And here we have a DM transmitter as well as receiver. Okay, so you just keep remember for what you have discussed in DPCM, you are just replacing with the prediction filter by delay, and there also having quantizer, here also having quantizer, and same x of KTS which represents sampled input, x cap of KTS which is delayed element. So that's a difference. And one bit quantizer, whatever I have told you, know, plus delta, minus delta, plus delta means 1, minus delta means 0. That binary data we are receiving at the B of KTS. So the summation of that delayed element and binary data, so which give called accumulator. What we will do accumulator? So two processes happening here. So one is addition, another one is delaying that added data. So that is accumulator. The final binary data is transmitted to the channel. Okay, so that's explained here. The summer in the accumulator adds quantizer output with the previous sample approximation value. Okay, so delayed by one sample period. So everything already explained. And a reconstruction of DM, the same what we have seen in a receiver, instead of prediction filter, here delay element, their decoder was there, here low pass filter is there. Why we are going for low pass filter? After converting your binary signal into a analog signal or your continuous time signal, so we have a extra noise in the channel. So we need to suppress that noise and we need to get a exact output. So that's what we are using here, low pass filter. So after receiving that input, accumulator unit, here it will do delay element as well as summing block, and it's passed to the low pass filter, getting the exact output what we are transmitted. The same thing only here I discussed. And what is the advantage or disadvantage of DM? So delta modulator offers two unique features. One, no need of word framing because here only one bit, and simple design for both transmitter and receiver. But here drawback is two things is that slope overload distortion and granular noise. Okay, slope overload distortion and granular noise are the disadvantage of digital delta modulation. Okay, so why we are going for delta modulation? So delta modulation, here we are going to transmit only a single bit. Okay, a single bit, either 0 or 1, so based on the signal. So in whereas PCM we transmitted bunch of bits. So here it's avoided in delta modulation in transmitter and receiver, just like your DPCM transmitter and receiver. Okay, so I hope you understand about what is delta modulation. Thank you.